Remember impulse from year 12? If delta t equals delta p is change in momentum. This all comes from this F equals ma, which we learned in year 10, I think it was. Because if you look at that, F equals ma, it's the same as m times delta v over delta t, right? So we could bring that becomes F times delta t equals m times delta v, which is the same as delta p, because the mass doesn't change. So basically, that comes from there. Now, impulse, we get lots of questions in year 12 on this, because basically we have a whole bunch of situations where there are different situations where the momentum stays the constant, and what they're trying to get at is that you understand that change in momentum stays constant, and the amount of time momentum changes determines the amount of force, because you've got these two things multiplying. So when your head hits a brick wall, boom, and your head was going at 30 meters a second in a car, then if that change in momentum from the mass of your head times 30 to the mass of your head times 0, this is your delta p, if that happens over a long period of time, force is very little, your head feels alright. If it happens very quickly, the force is very high and you suffer brain damage. So they use all sorts of things. You've got to be able to explain why a crash helmet is used. And in all these questions, I want you to be able to use that one. Say what's going to happen, and then talk about how the change in momentum is constant. F times delta t, change in momentum is constant, and the delta t is small, and the force must be high. There's the year 12 question where if you get thrown against a fence, or a boulder hits a fence and it comes to a stop, if the fence is quite springy, then the force is less. If the fence is very rigid, the force is higher, because it stops the boulder. Both cases the boulder gets stopped, so delta p is the same. If delta p is the same and delta t takes a little longer because the fence moves a little bit, then the F is decreased. You've got all these situations where we're seeing this. I think that's all I'll say in this little one right now, but yeah, I'll do another one